This question says compute your average velocity in the following two cases. First, you walk 73.2 meter at a speed of 1.22 meter per second and then run 73.2 meter at a speed of 3.05 meter per second along a straight track. B part, you walk for 1 minute at a speed of 1.22 meter per second and then run for 1 minute at 3.05 meter per second along a straight track. C part, graph x versus t for both cases and indicate how the average velocity is found on the graph. Okay, so see what we can do. We can make it into two parts. In first part we will be solving the A section, and in the second part we will be solving the B part. Okay, yeah. So in the A part it is saying v1 given as 1.22 meter per second. v1 is basically the speed, this one. S1, the distance is 73.2 meter. Now v2 is given as 3.05 meter per second and S2 is given as 73.2 meter. Now if you want to find out the average velocity, here average velocity, it can be written as total displacement upon total time. Since the person is moving on a straight track, so in this case the distance and displacement will be same. So for total displacement we can write it as S1 plus S2 and for total time we can write S1 upon V1 plus S2 upon V2. Okay, so after putting the value we will get 73.2 plus 73.2 upon 73.2 upon 1.22 plus 73.2 upon 3.05. So after solving this we will get the velocity average as 1.74 meter per second. So this part will give us the velocity 1.74 meter per second. Now coming to the second part. The second part is saying the t1 is given as 1 minute. So we are writing 1 minute as 60 seconds at a speed of 1.22 meter per second. It means v1 is given as 1.22 meter per second. Again the t2 is given as 1 minute, which we can write as 60 seconds, and v2 is given as 3.05 meter per second. So in this case also average velocity will be total displacement upon total time. So in this case again since it is moving on a straight track, so the distance and displacement will be same. So for total displacement what we can write is v1 into t1 plus v2 into t2 upon total time, which is t1 plus t2. So after feeding the value we will get 1.22 into 60 plus 3.05 into 60 upon 60 plus 60. So after solving this we will get a value of 2.14 meter per second. Okay, now coming to C part, which is plotting x versus t. So let me draw here. This is x and this is t. Here also this axis is x and this axis is t. So for the A part, we know the x versus t graph, the slope of the curve gives the velocity, right? So the first person is moving. The first person is moving with two velocity. One is this one and the second one is this one, right? So the first arc that we are going to draw will be of 1.22. The slope will be 1.22 and the next line will be having a slope of 3.05. Okay, so first we will be marking the distance 73.2. okay, so while marking we can write this point as 73.2. okay, and we can again plot this point as 146.2. now from the slope curve we can find out, like for example, suppose the first part of this, what we have, let me again write it here for better clarity. V1 is 1.22 and S1 is 73.2. S1 73.2 and V1 is 1.22. I think it is same. Yeah. So we know that the velocity is the slope. We can write it as S1 upon t. So from here we can find out the value of t, which will be S1 upon V1. So we can feed the value 73.2 upon 1.22. so this will give us the value of time. So the value of time which we will get here, we can plot it directly, and if we calculate the value of this time, we will be getting a value of time is approximately 60 seconds, right? So if we plot this curve, so we can put this point as 60. Again for the second part, in this case again for second part, what we can write, S2 and V2 is given, right? S2 and V2 is given. S2 is 73.2 and V2 is 3.05. 73.2 and 3.05. So if we find out, we write V2 equal to S2 upon T2. So from here we can write T2 equal to S2 upon V2, and if we feed the value, we will get 73.2 upon 3.05. and this point, if we calculate, I think we will get a approximate value of, let me check, yeah, so this value will be 24. So this T2 is coming after T1 has been completed. So we will just add this T1 and T2, and we will plot it on the here. So 60 plus this 24, we will get a value of 84. Okay, so the first part we will get it like this. This will be our first part, and the second part, if we draw, this will be our second part. So this slope will give us the V2 part, and this slope will give us the V1 part, right? V1 and V2 already written above, or let me write it here also, 1.22, and V2 is 3.05. okay, so in the similar fashion we can draw in this also. In the second part, the T1 and T2 is given, so let me plot the point, the time point first. 60 and 120 we have already plotted, so here also let me write first part. What's given? T1 is given as 60 seconds, and V1 is given as 1.22 meter per second, right? So from here also we can calculate x1 equal to v1 into t1. If we calculate it, we will get a value of, this value will get as 73.2, right? So this 73.2 we are getting, we can plot this point as, suppose this is 60, we can plot this point as 73.2. so the first part will be drawn like this, right? And this slope will, this one gives a value of v1, which will be basically 1.22. the slope will be 1.22. now for the second part, let me draw second part here. Again, T2 is given as 60 seconds, and V2 is, in the second part, the V2 is given as 3.05, right? 3.05. so from here we can calculate x2 equal to V2 into T2, that is 3.05 into 60. so if we calculate this value, it will give us a value of 183. okay, so we know that this 183 comes after x1 got completed, so we can add this 183 with this x1 to plot on the curve, and after adding x1 plus x2 we will get a value of 256.2. so we can plot this point on the curve. So here we are writing 256.2, and we can extend this dotted line, make 120, and we can draw this line. Let me draw it clearly. Yeah, so this line has a slope of v2, which will be equal to 3.05. So this is the third part. So this is how we solve this question.